My name is Terry Jo Lovass, and I am the ISGAN Communications Working Group Leader. So here's the agenda for today's webinar. I will be telling you a little bit about ISGAN and the Lighthouse project to give you some background, and then I will hand over to Brani, Klaus, and the rest of the panel to discuss this phase, which is foresight and strategic decision-making. So what is ISGAN? It's this International Smart Grid Action Network. It is an International Energy Agency Technology Collaboration Program that was an initiative of the Clean Energy Ministerial. ISGAN is the only global government-to-government forum on smart grids. We are a group of national experts from 25 countries and the European Commission. You can go to the next slide, please. Sorry. We are a group of national experts from 25 countries and the European Commission committed to supporting the global shift towards smarter and more reliable electricity distribution systems, which are key to meeting clean energy goals. Next. Our vision is to accelerate progress on key aspects of smart grid policy, technology, and investment. ISGAN emphasizes the importance of strong, reliable, resilient, flexible, and affordable power grids, supported by the digitalization of the electricity system for achievement of goals on the grid edge, which includes the integration of electric vehicles, renewable energies, energy storage, and demand-side management. We implement this through the facilitation of dynamic knowledge sharing, technical assistance, peer review, and project coordination between contracting parties in the area. Business models, technology system development, workforce skills and knowledge, and user and consumer engagement. Next slide. Activities we leverage to achieve this include outputs such as policy briefs, technical and discussion papers, conference presentations, and webinars like this one. If you would like to explore more about what we do, please visit our website. Next slide. So what is the Lighthouse project and how does that fit in here? As the members of ISGAN explored the planning and implementation of smart distribution grids, it became apparent that these processes include many external influencing forces and actors with diverse roles and goals. This often results in actors operating in silos, under conditions of uncertainty, and within governance frameworks that are slow to adapt. Next. So, in 2023, the Lighthouse project was launched to facilitate collaboration between these actors and across countries and sectors, helping to overcome challenges like fragmented planning and slow policy changes. To achieve this, we need to shift in mindset from the traditional reactive grid planning approaches that rely on rigid master plans and are reactive and static to a forward-looking, adaptive, and scenario-based planning approach that can effectively manage long-term uncertainties. Next. This new approach envisages planning and decision-making that are dynamic, continuously evolving, and built on collaboration among key actors. It embraces complexity, incorporating scenario-based planning, risk assessments, and resilience measures to navigate an ever more unpredictable energy landscape. And it prioritizes strategic intelligence over historical trends. In today's fast-changing world, relying solely on past data is no longer viable. Decision makers need advanced modeling, real-time data, and strategic foresight to stay ahead. Next. Phase 1 of the project, the Lighthouse project, was from November 2023 to October 2024 and resulted in a series of tangible outcomes, including a policy brief to SIM 17, a pilot of the Knowledge Hub, a global workshop series of 5 public events, a new collaboration between our working groups 3 and 7, enhanced online communication, and a framework on long-term planning and implementation. That framework is what we will be exploring during this workshop series. Next. Phase 2 of the Lighthouse project began in October 2024 and is even more ambitious, with activities around knowledge-sharing processes focused on improving coordination and collaboration between key actors involved in complex distribution grid planning and implementation processes. A casebook development showcasing pioneering global examples of innovation in long-term planning and implementation of smart distribution grids. A Knowledge Hub is a resource for people to learn more about the framework. You will find a link to the Knowledge Hub at the bottom of the Lighthouse website page. workshops with key actor groups to explore challenges and opportunities in advanced grid planning processes, deep dive activities by ISGAN working groups on key technologies and aspects relevant to the Lighthouse project theme, collaboration with other international organizations and work streams, and this webinar series exploring key aspects of long-term planning and implementation of smart distribution grids with the help of the new framework that was developed in Phase 1. These activities will combine to deliver a set of high-impact knowledge projects to be launched in conjunction with the Clean Energy Ministerial next year. So to tell you more about the Lighthouse framework, the focus of today's webinar, and introduce you to our panelists, I will now hand over to Branislav Iglar from the Austrian Institute of Technology.
Thank you, Terry Jo. I was too quick on the slides, but now it's the right time. So today at the second webinar, we have 5 panelists. The first is Klaus Kubeczko, my colleague from the Center for Innovation Systems and Policy. Klaus is actually an electrical engineer from his background, but he's working on transformation innovation policy, and is working as a senior expert advisor and scientist at AIT. Helvi Brunner, also a colleague of mine, is the thematic coordinator for power system planning and operation. He's the Austrian EXCO member to ISGAN, and is also sitting in the CIRET Technological Committee. Pratapan Moodley was also at the first webinar. We're very happy to have him. He works at SANEDI, the South African National Energy and Development Institution, where he's the general manager, and he's heading the Applied Energy Research Development and Innovation Division, and he's also the South African delegate, the EXCO member to ISGAN. Antonio Iliceto is the Italian EXCO member. He's working at Terna in Italy, the Italian TSO, and he's currently the co-chair of the ETIPSNet, and is expert for research, development, and innovation in the field of sector coupling for ENTSO-E. And Henrik Thurberg is the regional manager for Småland and Halland at E.ON in southern Sweden. And his area of expertise is to foster the dialogue with municipalities and companies supporting green transition. And now I hand over to my colleague Klaus to explain the Lighthouse framework.
Thank you, Branislav. Hello from my side. I will briefly outline the basic elements of the framework for forward-looking long-term planning and smart distribution grids developed by AIT, by ISGAN, collaboration of AIT and many other organizations, of course. ISGAN has developed this framework to support key actors in the complex task of planning and developing smart, sustainable distribution grids for the future. The framework provides a structured approach to enhance understanding and facilitate the multilateral dialogue necessary to advance global distribution grid planning. Its purpose is to help actors to navigate systems complexity and respond to multidimensional uncertainties. At its core, the framework is a tool for fostering shared understanding and strengthening collaboration around common challenges in long-term distribution grid plannings and implementation, including many actors that I'll explain briefly at the next slide, and other framework conditions. So the framework condition the framework consists of three fundamental components. It marks the conditions underpinning. So I'm sorry, I'm talking now about the lower right red area that's named framework conditions. It marks the conditions underpinning for forward-looking planning processes, preconditions to enable a proactive and adaptive planning approach. And this includes legal aspects, it includes information bases, actor networks and collaboration networks that are there when those strategic plans have to be developed. For the new framework, we have identified, with the help of many practitioners all over the world, 5 phases of long-term planning and implementation in a consecutive order. It starts with foresight and strategic intelligence as the phase where data and information generation is taking place. And it's the phase in which shared understanding between actors should emerge, and it is the basis for the second phase in strategic decision making, in which we focus in this webinar. The third phase then that builds on this phase 2, we will today discuss more in detail, leads to operational phase of long-term planning and of assessment of options and decision support, and then of course allowing to implement those plans in practice. On the left side, you see a frame for the key actors that we have identified that have formal roles in planning, but also roles in grid, not in grid planning, but in other related planning processes. So the key actor groups are different for all 5 phases, but particularly for today's webinar, it's important to take into account all the actor groups that are mentioned here, from energy policymakers to regulators to local and regional governments, and of course then the distribution system operators, management, or the utilities, if you wish, to then also put these strategic plans into operational plans. And last but not least, an actor group that hasn't been involved in the previous more reactive phase of 5-year plans are the grid owners, as this group which can then really make strategic decisions happen, and that includes private and public owners, that may be cities or provinces, but also, of course, in many countries, private companies that own the grids. Okay, so I think this is, for the moment, what is necessary and possible in this short webinar to give you an overview for. Thanks.
So I have the first question to our panelists. We were talking about the challenges the last time, so and there are many, but somehow we thought about organizing a second one, because there are very many topics to focus more on the solutions. And I would maybe take as first my colleague Helfried Brunner. Hetty, are you here?
Yes, I am.
Hello. So you work at AIT, and basically you work very closely with utilities, with distribution system operators. I know from the discussions with you that there are already many solutions for these very early planning phases for the challenges that the DSO have. Which solutions are actually available? Are there solutions that are not enrolled already for the very early phases of the grid planning process?
So maybe before going into that details, just a framework condition which is available. So just to clarify about strategic and long-term grid planning, so that's usually, and in particular, it's in the DACH region. It's quite similar in a lot of countries. It's actually not that a long-term grid planning. So what is the future in 20 years and adapting the grid on that? So it's more reacting on what's going to happen in the next couple of years. There is somewhere a grid development projects, a new residential areas. There is a big power plant or a consumer to be connected. Industrial sites are going to be, so that's driving then a grid planning process in addition to just replacement due to the age of the infrastructure, so the current the normal asset management. And so what's actually still quite new for the grid planners is to consider different technology roadmaps, technology rollouts, and what is going to be expected where and when. So that's the big question. I think that was also in the first workshop one of the topics. And here it's more, there are tools available with geo-referenced information where you can include targets for different technologies once you know that. So let's assume we have clear targets from the politician decision makers, but we know, second part of the question, the targets are still moving. So you need to allocate maybe also national targets on your individual grid. And here, one specific aspect in the Austrian situation, which is also very much true for Switzerland and Germany. We in Austria, we have 120 grid operators. So it's let's say it's a rather small area where they need to project what in future is going to happen. And the people, there are let's say geo-reference tools like QGIS and with information is available, but so far the people in the grid planning departments are not used to use these tools. So it's very much also in educating the people in new tools and applying new tools. And that's also related to technology providers to connect different tools. So there are some kind like QGIS tools where you can investigate what's going to happen where, but that need then to be connected with the load flow simulation, so the classical power flow simulation in the power system. But we also need to have accurate availability of data and grid representations to map that with the future, how it is going to be expected. And here, which is also some kind of still challenge for the grid operators. So just to let you know, we had yesterday our autumn meeting of the technology platform Smart Grids Austria, and here was a big discussions about using data. And that's, you need also good data for your simulations and investigations, not just what is the target, where do I aim, but what is the basis and how accurate is data, because as we know from science, if you can have the best simulation tool, the best model, but garbage in is garbage out. So and that's the important thing to utilize grid operators, grid planners already in this early stage to use partly available tools and to interconnect that. But we need to take into consideration that's mainly electrical engineers, power engineers, and not software developers.
So basically, there are two big challenges. The first one being the integration of these different dimensions that are there. So they have to consider mobility and heating demand and basically data sources that they were not dealing with before. And on the other side, it's a matter of also using all these tools. You need to have the skills and I guess also the interest to do so. Yeah. Do you see here some kind of a change?
Yes. Yes, and that's why also some activities like this Lighthouse project is so important, to bring different stakeholders with different perspectives together and to learn from each other and to talk to each other. And I like the example you gave, Branislav, is mobility. Yeah? Even mobility experts have no clear idea how the mobility will look like in 10, 15 years. So how should grid operators do that? So then this is to have this constant knowledge exchange between different entities involved in these planning processes. And of course, this is even still on a technological side, but then take into consideration on a regional, local level. So it's all about what is about land use. Yeah, how are the legal requirements there? Are you allowed to build something somewhere? Yeah, and also, so let's say this local infrastructure and development planners and regional needs to be involved, because we need cooperations between the power system infrastructure providers and other infrastructure planners and providers and decision makers. And here it's finally also all about political decision makers.
Thank you. I find the last sentence that you said quite interesting, and it brings me actually to Henrik, because from what I've heard, you are working on the integration processes and foster the dialogue with municipalities. Is this something common in Sweden? Is it already in the work life, or is it just E.ON being the forerunner?
No, I don't think that we are in a special way a forerunner in this matter, but we take this subject very seriously, because we have understood that in some extent you can see this question as a technical question, a data-related question, but my perspective and my main message is that it's more an interpersonal question.
Yes.
You need the background from the technical side, but then we have to move the discussion in interpersonal meetings to arrange foremost a common understanding. Many times we have different pictures of the reality. The municipality maybe have a clear vision that this connection shouldn't take more than a year, but in the real life it takes at least 5 years. We need to create a common understanding. And the other two main themes is to create the understanding, collaborate and coordinate in this picture. And I've prepared a few, try to summarize the picture in a few lines, if I may.
Yes,
take
please.
them here, if it fits in the scheme here.
Absolutely.
And as I said, the biggest lesson we have learned so far is that if we only take the step outside the door, so to speak, if we only start talking to municipalities and authorities when the permit application is on the table, it's already too late. We must be more in advance outside the door. We need to pick up the phone in an early stage, arrange the meeting, so that we can share our pictures well in advance. Because the electrification is moving so fast these days, as you all know, and our grids must expand very fast and adapt very quickly. But as I said, the real bottleneck is not always the technical capacity. As the earlier speaker said here, it's also the permitting, the land use conflicts, and as earlier mentioned, the lack of shared forecasts. So the only medicine to this is that an early structured collaboration change this picture when we sit together, municipalities, regional authorities, together with us, and we exchange our picture scenarios, maybe 3, 4, 5, 10 years ahead. Then we can make some magic, and we can avoid costly delays. We can find smarter solutions together and build projects that the local communities really accept. And practically, this means 3 things as I see it. First, establish a joint planning forum on a regular basis. And the key word here is a regular basis. It's not enough just one time. We need it on a regular basis. Secondly, publish a transparent network development plan, which looks 10 years ahead, and this must also be on a regular basis. And third, introduce a pre-application dialogue. As I said before, we need to be one step ahead with the permitting authorities, so we identify environmental and land use risk before they become real roadblocks. So my message is simple: plan with the municipalities, not against them. Transparency and early engagement reduce costs, accelerate the energy transition, and ultimately deliver better outcomes for citizens and customers. Thank you.
Thanks, Henrik. That's actually also something that Helfried mentioned before. I mean, it's about the commitment, about the common view, but also because the other involved stakeholders do have knowledge that the DSOs do not have or will not have. So this common dialogue also increases the knowledge base in that is necessary for decisions in the planning phase. Very interesting. Thank you. And well, I would like to look now across the equator to South Africa to see how the processes or the improvement looks like in other regions. Prataban, is there do you see any changes in these early planning stages in the South African environment?
Thanks so much for the opportunity, and I think I'm very glad to share the platform with the colleagues from across the world. I think many similarities in the South African environment when it comes to distribution grid planning, but some nuances, and maybe I should start with the nuances. So we do have in South Africa over 170 licensed distribution entities. All of these licensed distribution entities are predominantly local government owned. So they, most of them are actually municipality owned. Some of the larger ones are owned by the large metropolitan areas. And then we do have a function within the incumbent state utility, ESCOM, that also provides distribution services. So there isn't a separation from the network owners to, let's say, local government and local policymakers, which is a big difference that I've seen in the South African context. The other big difference in the South African context, because South Africa is still a developing world country, there's part of it is that there's still this very significant energy demand growth just for normal energy services. which needs to be factored in terms of the planning aspects. So that's a big thing. And then there's a lot of transition towards a lot more of the new applications and adoption of new technologies, similar experiences, around transportation, a significant amount of electric vehicles coming towards the planning aspects of it. There's a lot of local data centers in the various regions and the various territories of the municipalities. So it's not widely spread across the country. It becomes very, very specific to specific areas that needs to be taken into account, because the energy consumption from these data centers seems to be very significant. They are also new, let's say, industries, especially when it comes to critical minerals, which we find that South Africa is a home to predominantly platinum, usually for the green hydrogen industry. There's a lot of manganese and vanadium, which is, I think, touted as key chemical inputs towards battery storage and different types of chemical storage. So also there's these specific new loads that seems to be coming through. But in the main, we still have the same approach in terms of understanding the technology. We have the approach around planning processes, the data and monitoring, and then lastly around policies and so forth. So when we start with technology, it's really about understanding what are these new demand technologies that's going to be coming through, how geographically diverse and spaced are they, and how do you take that into consideration. The last time I joined the platform, I also mentioned there's about 6% of citizens in the country that has never had access to electricity. And the government's, driving policy around off-grid solutions, which needs to be taken into account from a planning perspective. Over the kind of the planning period, the 10 to 15-year period, we find that these off-grid solutions might become hybrid and connected to the grid as the grid starts expanding towards these unelectrified communities, which needs to be factored in the planning processes. I think when it comes to planning, we have the interesting aspects around demand forecasting. Like I mentioned, not just constant demand, but as a developing country, generally an increase in demand rates. And then the various scenario planning, where would these electric vehicles typically be adopted? Where will be the early adopters? Where should we be strengthening the distribution grids to accommodate the early adopters of these loads and these significant loads? Also, we find that self-provisioning and some of the regulations for self-provisioning, like rooftop PV and distributed energy storage, has really opened up the market, and we've got about 7 gigawatts, which is actually exceeding the large-scale renewable capacity in the country. And how does that offset the demand, and it's kind of behind the meter, so you need to be able to quantify that. And so a lot of engagement with local government planners, the regulators, who actually have to keep a track of the installations. And then when we get to data and monitoring solutions, a lot more, I think, reliance on smart sensors, whether it's a smart meter or digital twins or asset management. Given that the historical data, although it's been used quite widely for load forecasting, the historical data needs to be complemented with new sensing data that gives an up-to-date view of the load and the growth of the load or the decline of the load in some circumstances. And all of that needs to be taken into account. And then lastly, just a national policy and regulation, but also local policy and regulation needs to be taken into account. You know, does it change the barriers to entry for different types of technology, increase adoption of self-provisioning technologies and so forth? You know, it becomes a highly more complex environment. But I'm very glad to hear that, you know, we also have in South Africa a national planners forum, which has been established. But I think the complexity of this, of the planning functions going forward, will need to take into account all of these complexities. I think we are grateful that we have the forum established, but I think it needs to shift gears. A lot more focus around stakeholder engagements, especially with communities and so forth, becoming you know, an incredibly important aspect towards the distribution grid planning. And then maybe finally, you know, generally there's been a wide underinvestment in distribution infrastructure. And most of this infrastructure is coming to you know, the end of life, or a significant part of this infrastructure is coming to end of life. So, you know, thinking about how do you strengthen these grids, how do you create, you know, contingencies like N-1, N-2 criteria. It's not usually the case, but also upgrading and uprating infrastructure is part of the conversation generally in the large load centers. Thank you.
Thank you so much. Very interesting. So basically, you have the challenge of developing the network at the same time as you have to face new technologies coming as new kind of loads, which basically are challenging, but they also are opportunity to flexibilize the system more, so that you basically can follow the most cost effective pathway in the planning. Very interesting. Klaus, now from your perspective as an expert on transition processes, do you see here, from what has been said, solutions that are suitable for the adoption to reach the targets?
Yeah, thanks. So first of all, thanks to the speakers before. I mean, there already this indication that there is the request for forums, and that they are already established to some extent. I think this is a global, also for other countries, an important input. But let me first go to the institution level, or to the framework conditions as we have named them in our framework. The legal basis in Europe now is there to extend the planning periods also formally. So DSOs are provided, as Hendrik was saying, they're even provided by law of this 10-year planning processes. And in the respect to the moving target, it's also important to say that this regulation also includes revolving. So every second year, these plans have to be adapted. But of course, first of all, they have to be made. And I mean, one point that we haven't discussed yet, also the reason why we have been why we got this attention on the global level is that distribution planners are now estimating a doubling of the investments globally. So I mean, this already means, I mean, there is urgency. This also potentially means that you might need twice as many planners, or you have to become much more efficient in this long-term planning process. And those are things for which solutions, I don't know if they are there. I mean, we hear now and then that a lot of people are hired, but I think this is also an aspect in this long term, to have the people with the knowledge, with the skills to do this planning processes.
Thank you. Now I have a question specifically for Helfried. Are there already tools or methods available to tackle the trilemma between the data protection level of the detail necessary and simulation?
This is a very tough question, but I need to be honest, because it's actually less concerning concrete solutions how to tackle that. It's more in which boundary conditions are you working. So for instance, from a European perspective, with all these data protection rules we have, this needs to have more attention, maybe like in other countries where not that big issue is on that, and so you can focus on the other ones. And I think, of course, that's not, I guess, not the answer you are hoping for, but it's very dependent on which framework you are working in. Yeah. Where is more emphasis? So I think we don't have partners here from China on the phone, because data protection most probably there is not the big issue, yeah, and you can fully focus on the other two aspects. But yeah, it needs to be a commonly agreed approach within the country or region you are actually finally.
And if you think now about your work in Austria, do you face here limitations in terms of yes?
Yes. And that's clear, because we need to apply particular of the data protection and privacy part. We need to follow the protection data protection rules from the European side, which are also already implemented also in Austria, of course. And here, as soon as I said in my initial statement, so to have a real accurate planning, you have to have some georeferenced information available as well. And even if we don't have names, addresses of customers, so the regulation says if it is with let's say with small effort possible to find out who is living there, and as soon as you have georeferenced data, there is other data where you find out who is living there. You cannot easily do that, yeah? And we have here limitations. And on the other hand, we still have, let's say, also some kind of Austrian specificum, how to interpret the GPDR, so the protection rules from the European perspective, because let's say the legal representatives from the Austrian DSO do have the legal opinion that it's not allowed to use smart meter data for daily operation. If I look maybe even to Antonio, having the Italian perspective, so Italians don't care. They say, of course, we can use it. Yeah? But that's also that's some kind of legal dependency. And here that's where the Austrian legal experts ask now for clarification in the Austrian laws, and then the upcoming Electricity Industry Act, there will be specifically the mentioning that DSOs are allowed to use smart meter data for grid planning and operation. And so this is a very Austrian specifica that the interpretation it's not allowed. In other countries, even Europe, don't care. Yeah? And
but
these
this
are two.
Is not decided yet, right?
This is not decided yet. Yeah. And so you can see how small details can affect the entire processes behind, yeah? And also having in mind this trilemma.
Indeed, smart meter data, beside their primary use to bill, to make the settlement and bills, should be used first and foremost by the individual customer to understand his load profile, what is the maximum power he consumed, when it was, and so to calibrate the best also supply contract he can get. And but then to be used by others actors at least they have to be aggregated. Iglar, I have also a contribution about this question, which
Yes,
I have some
please,
slide
please.
to. Can I take the screen, share the screen? And then it's about Italy. We talked today about solutions. This is something that we have since few months. It's a new instrument for efficient green planning. We even change organization in Terna and in distributor companies. Terna is the Italian TSO, introducing micro zones and a specific portal. So I will go through a quick framework condition. We are receiving connection requests. This is a graphic about renewables, but then we have data also from storage and consumers, which are overwhelming us. You see the number, there are 349 gigawatt requests, and these are just the request. And it's not even updated because I think this data is from end of last year. So we assist at the paradigm shift. Traditionally, the load forecast was done by the grid operator, distribution or transmission, and basing on historical terms, some new loads, new initiative, new building, new factories. And now we have to do the opposite job. We receive so many connection requests that we have to check which are the ones which will arrive really to the end. There is this tentative to make saturation of the network because everybody else is doing this, so you also feel you have to have your part of the cake. So it's completely different. The load forecast, instead of being us to forecast with some econometric generic model, we have to pick from the input we have. So it has been, and you see here, the connection requests are very different from region, from categories. So we made a database, a very large database, which then became also a portal with all this kind of information. And just to give you some number, you can see here, sorry, the skyrocketing of connection requests. It is very clear from this number. Don't even need to look at the number, but the graphic is very evident. And here we are talking about all distribution and transmission together. That's why most of them are solar plants. So, and if this is a situation, we have to be organized. We cannot just make a pile of connection requests and then go one by one. We have to completely re-engineer the system. So we made this very large database with geographical distribution, technology distribution, split by storage, consumer, and generation. And I would like here to show a focus on the offshore. Until 2 years ago, it was deemed impossible to have offshore grids in the Mediterranean due to high depth. But now we have such a strong acceleration. You see the number 86, but now, as my colleagues tell me, it's more than 100 gigawatt request of connection. But the installed is 30 megawatt. It's not a typo. 30 megawatt, but we have more than 100 gigawatt requests for connection. And we are obliged to develop solution connection technically, which have to be sound, economically affordable for all of them. But guessing which one will become more or less real. There is these graphics are taken from the publication of the latest version National Development Plan of the grid, and we made also some analysis. This is, of course, a public document. So you can see here again the zoom on offshore depth. In the upper graphic, there is the clusterization between power, between distance from the coast and the depth. And you can see that even if most are with a low, not so high depth and not so high power, there are some which seems to be incredible. Even 2,000 meters and almost 3,000 meters. Of course, this will be floating technology. So we made also some technology analysis on the bottom part of the graphic, both AC and DC, depending on the distance and the depth, which solutions are there. This is because we need to know before we propose a technical connection solution, which technologies are there. Some are mature, some are in developing phase, some are still to come. So in the end, we took a new approach. We have to integrate all voltage levels, and we have to integrate all the distribution components. So we started with the ones which are directly connected to national transmission grid. So now it has been enshrined in a law, and with some application details by the regulator. So periodically and comprehensively, all the distributors must send to Terna a report about all the system to connected and to be connected to medium and low voltage. So this is aggregated in a huge database. And you can see that the data from the so-called embedded, what the TSO doesn't directly control, is definitely not negligible. We're talking about more than 50 gigawatt. So of course we cannot do without it. And this is not behind the meter, because this is something that is still measurable with the meter. So just to make an example, we made also calculation how much this only the connection requests today, actually at last year, because this is taken from last year version, how much they cover the European and national target of decarbonization. And the answer is not only they cover already today, these are long-term targets, but they go beyond in most region and definitely overall, because we have national targets. So this alone tells us that it's something which is really overwhelming. So the grid operator, both distributor transmission, has to do really a difficult job, especially, and we cannot to understand which will be the ones really to arrive to an industrialization. Otherwise, we risk to have a stranded asset and, in general, unoptimal, highly unoptimal connection solution. So, in the end, just to show that also storage, we have very high number of storages. You see here more than 100 gigawatt hour, of which the classic hydro pumping is a minority, and we have storage in grid connected, in generation plant connected, and the consumer plant connected. And here again, we are talking about 10th of gigawatt. And also consumer, if you see the right graphic, it's again like renewables, this is skyrocketing. So consumers are asking connection, and for example, data center is very particular and also particular stressful for the network. You see on the bottom graphic, the data center are arriving in the range of tens of gigawatts. So everybody wants a grid. I remember some years ago in ISGAN, maybe the first work I did in ISGAN was to counter the fact that we will not need the grid in the future, because we have a microgrid. We will have some, we will have the web of cells. If you remember, that was also work from Luciano Martini. And somebody said, the grid can be there as a backup or even not be there. And now everybody wants to be in the grid. So in our work, we cluster also, for example, for transport. I don't show here the electromobility on the road, but just to show that even rail on the left and even the ports. This is called irony on the right side of the graphic. Even there, we are having many and large connection requests. So this is the other phenomenon of electrification of consumption, which today are not electrified. So we have sector coupling, we have new loads, also some desalination plants in Sicily. So everything is completely changing. So the model we adopted is based on territorial integration through microzone. Microzone, you see now in the first round, we identified 76. So more or less like the provinces. In Italy, we have 20 regions and about 100 provinces. But of course, they are identified on electrical topography. The concept of microzone is a portion of the national transmission grid, because we are doing this at the transmission level, which allows all the intrazonal constraints on energy transport to be modeled effectively, because otherwise you don't This is the other thing. You have to avoid congestions, but maintaining modeling simplicity instead of going to a nodal approach. Theoretically, from economic point of view, nodal approach has some advantages, but then the nodes would become many more order of magnitude, not only in the order of 100. So, and the philosophy is that instead of managing a single connection request, we have to look at, in that area, in that microzone, to all of them which are coming now, are already in the database or are supposed to come, because we also have differentiation of stage. The first request, the first technical solution provided, acceptance of it. So we also look at the various steps to have a comprehensive solution for optimal, or at least tending to be optimal. In practice, we have a portal named Terra, which is a digital portal, only from this year, from June, you see, which contains all this data, and they're available to all administration, local administration, and also to all proposers. So this promotes the maximum transparency on data and information, and promoting the rationalization, because if I go and see, I want to do a connection request before I enter this portal and see what is the situation in the exact location where I want to ask a connection. This is good, this is not good, is the big topic about hosting capacity. So this is going already to do something on the hosting capacity, and stakeholders involvement with a lot of transparency. Of course, this aspect of which was very well mentioned by the previous speakers, that we have to, we have to plan not against the local administration, but with them. It's very much true, I think.
Yeah.
And so you see here the platform content, and it's part of the more the broader digital evolution innovation policy of Terna. We dedicated 2 billion euros to digitalization. I have also other details of this. I can send them the presentation, and I think this is a solution which can be also used as a best practice.
This is really exciting, especially how you combine the solutions from the digitalization and data side with the regional approach. So to basically break the problem down where it needs to be solved. I'm really happy that you basically finished our discussion today with such a presentation. Italy has always been a forerunner in terms of innovations in the energy system. We're also looking to what happens in Italy, in Austria, to get some inspiration. I hope everybody got some inspiration for today. I would like to thank to all our speakers for the interesting insights. It's quite challenging to find one single time for all the different time zones, but I think, Antonio, you're currently in Montreal, so will be a wake-up presentation basically, while for our Australian friends it's already a time to sleep. And I'm heading over to Terry Jo.
Yeah, thanks, Franny, and you summed it up very well there. Thank you to all our panelists, everyone who joined us today, and we hope that you can join us for our third in this series on October 29th, which is on long-term planning and how that fits into this whole framework. And the registration portal has just been dropped in the chat there. So that's it for tonight. Well, today for many of you. Thanks for joining us, and we'll hopefully see you next time. Bye-bye.
Thank you. Bye-bye.